Bismillahirrahmanirrahim. Assalamu alaikum girls. This is Miss Sumaira. Course name is Discrete Mathematics for BSIT student. Today's topic is conditionals and truth table. Conditionals. Let P and Q be propositions. The conditional statement P employs Q is the proposition if P then Q. The conditional statement P employs Q is false when P is true and Q is false and true otherwise. In the conditional statement P employs Q, P is called the hypothesis or antecedent or premise, and Q is called the conclusion or consequence. More about conditionals. A conditional statement is also called an implication. The truth table for the conditional statement P employs Q is shown in table. You can see the truth table for P employs Q. The first column represents proposition P and the second column represents proposition Q and the third column is going to be represent P employs Q. Here all the possible combinations are given for the proposition P and Q. Now interesting fact is when P is true and Q is false, it is the only possibility when P employ Q is false. In rest all the combination, it is true. When P is true, Q is true, it is true. When P is false, Q is true, it is again true. When P is false, Q is false, it is again true. So keep in mind that the only possibility when the first proposition is true and second is false, its answer is false. In all other, it remains true. Let's talk more about it. I make promise, if it is sunny, then we will go to the beach. In most of the problems, we are going to use logics as P, Q, but here we are using pictures. Like, if it is sunny, then we will go to the beach. Keep this promise in your mind. So you have my promise that if it is sunny, then we will go to the beach. The question is, did I keep it or not? We have to look what actually happened on the day of trip. The weather is bright and sunny. So the hypothesis, it is sunny, is true. We go to the beach. So the value of conclusion that we going to the beach is also true. Did I keep my promise? Yes, I did. It was sunny. We went to the beach. Keep going to other set of possibilities. On the day of scheduled trip, the weather was sunny. So hypothesis B is true. However, instead of going to beach, we go to a park. So the conclusion is false. So I asked from you that did I break my promise? Yes, I did. I said if it is sunny, then we are going to the beach. It was sunny, but we didn't go to the beach. So I break my promise. Now, what happens if it is not sunny? On the day of trip, it's raining outside. The truth value of the hypothesis P, if it is sunny, is false. What happened that if I decided to go to the beach? Anyway, I only said that we go to beach if weather was sunny. I didn't said anything about if it is not sunny. The question is, did I break my promise? I kept my promise because I promised about sunny weather. Now what's about if weather was not sunny and we didn't go to the beach? As weather was not sunny, the truth value of hypothesis P is false. My promise was if weather was sunny. Did I keep my promise? Yes, because I didn't make any promise if weather was not sunny. Summing up all the information in picture form and in truth values of proposition, we get truth table for P implies Q. Conditionals and terminologies used for conditional. You will encounter most, if not all, of the following ways to express this conditional statement P employs Q. If P, then Q, P employs Q. If P, Q, P only if Q, P is sufficient for Q, a sufficient condition for Q is P, Q if P, Q whenever P, Q when P, Q is necessary for P, a necessary condition for P is Q, Q follows from P, Q unless P, Q provided that P. See another example. Let P be the statement Maria learns discrete mathematics and Q the statement Maria will find a good job. Express the statement P employs Q as a statement in English. Come to the solution. P is a statement Maria learns discrete mathematics. Q is a statement Maria will find a good job. Then P employs Q represent the statement if Maria learns discrete mathematics, then she will find a good job. Converse, contrapositive and inverse. We can form some new conditional statements starting with the conditional statement P employs Q. In particular, there are three related conditional statements that occur so often that they have special names: converse, contrapositive, inverse. More about converse, contrapositive and inverse. Starting with the conditional statement P employs Q, the proposition Q employs P is called the converse of P employs Q. In this, we change the order of given conditional statement. That instead of P, Q here, and instead of Q, P here. The contrapositive of P employs Q is the proposition not of Q employs not of P. That if you observe, it is the not of converse. Mean if you just apply not on the converse statement, you get contrapositive. The proposition not of P implies not of Q is called the inverse of P employs Q. Mean if in the given statement, given proposition, we just apply not on both sides, then we get inverse of given conditional statement. Equivalent. Out of these three conditional statements formed from P employs Q, only the contrapositive always has the same truth values as P employs Q. When two compound propositions always have the same truth values, regardless of the truth values of its propositional variables, we call them equivalent. Hence, a conditional statement and its contrapositive are equivalent. The converse and the inverse of conditional statement are also called equivalent. Now looking at the truth table for equivalent, it's the statement conditional statement P employs Q, converse is Q employs P, inverse is not of P employs not of Q, and it's the contrapositive not of Q employs not of P. If you observe the whole truth table, then the statement P employs Q and its contrapositive both are having same truth values. So they are equivalent to each other, contrapositive and given conditional statement. Also, if you see the column for the converse and inverse, both are having same truth values. So converse and inverse are equivalent to each other. Now consider another example. Find the contrapositive, the converse, and the inverse of the conditional statement, the home team wins whenever it is raining. Now come to its solution. Because Q whenever P is one of the way express the conditional statement P employs Q. So it can also be written as if it is raining, then the home team wins. Consequently, the converse, that is Q employs P, is that is converting your given statement. If the home team wins, then it is raining. The contrapositive, that is applying not to the converse, is if the home team doesn't win, then it is not raining. The inverse, or applying not to the given statement, is if it is not raining, then the home team does not win. If you observe, then only the contrapositive is the same as the given statement.